Okay, let's unpack this. Today, we're diving deep into two distinct but really powerful ways of thinking. Thinking about how we discover insights, how we make decisions.
Yeah, we're talking about the foundations of understanding, really,
Roger.
especially in research, but also just, in practice.
And we're looking at two core concepts,
That's
right?
it. The data-driven approach on one hand and the theory-driven approach on the other.
Okay.
And what's interesting is how much these underpin, well, almost everything in modern knowledge. They're just fundamental starting points.
But quite different starting points.
Very different, yet both super prevalent, hugely important across so many fields. Science, business, you name it.
Right. So our mission today, for you listening, is to get clear on what each one actually means.
Explore what they're good at individually.
And I think this is key. Figure out how they can actually work together.
Yes, how they combine to give a sort of fuller picture.
Exactly. So shall we jump in with the first one? Data-driven.
Let's do it. So the data-driven approach, well, it basically says let the data speak.
Okay. No preconceived notions?
Ideally, not strong ones guiding the initial look. It's about finding patterns, associations, outcomes, just by analyzing the data you have.
Using statistics, algorithms, that sort of thing.
Precisely. You're not necessarily starting with a big theory or a specific hypothesis you're trying to prove. Instead, you're focused on what the raw data itself seems to reveal, looking for those trends, those structures that just sort of emerge.
Okay, I like the detective analogy you mentioned earlier. Walking into the room, not looking for a specific person, but just clues. Any
Yeah.
clues.
That's a great way to put it.
And you can see why this is huge now, right? With all the data floating around.
Oh, absolutely.
Like how my streaming service knows what I want to watch next. That feels very data-driven. They're spotting connections I wouldn't have thought of.
Exactly. That's often pure pattern matching on a massive scale. Things like machine learning, AI,
Yeah.
they're the perfect tools for this.
Because they can sift through complexity.
Yes. They excel at finding subtle, maybe non-linear patterns in huge data sets without a human needing to tell them what kind of pattern to look for first. It's incredibly powerful for uncovering hidden structures.
But, okay, if it's just about patterns emerging, is there a risk? Like finding connections that are just noise, coincidences.
That's the big question. And yes, definitely. That's a key limitation.
Finding something statistically significant, but it doesn't actually mean anything in the real world.
Exactly. Spurious correlations. Without some kind of guiding theory or context, you can easily end up there. Or just fitting your model too closely to one specific set of data.
Right, overfitting. Makes sense. Okay, so that's the power and a potential pitfall of letting the data lead. But what about the flip side? What if you do have a strong idea already? A hunch, a model in your head about how things work?
Well, that's where the theory-driven approach comes in.
The other side of the coin.
Precisely. It starts from the opposite direction. It really emphasizes having a conceptual framework, maybe an existing model, or like you said, a specific hypothesis first.
Okay.
That framework then guides the whole investigation or the application.
So you have a map from the start. You're testing something specific based on an existing idea.
Yes. You use the theory to predict relationships, and then you collect data or analyze existing data to see if those predictions hold up.
That sounds maybe more structured, rigorous even. It's about confirming or disproving something specific.
It often is, yes. It provides that structure.
But does it have a potential blind spot? Like maybe confirmation bias. You only look for evidence that fits your theory and miss other interesting stuff.
Another excellent point. Absolutely, that's a known risk.
If you're too locked into your framework.
You might overlook unexpected findings, things that contradict or could expand your current understanding. You might miss the novel insight because it doesn't fit the map you started with. And for this side, you have tools too. Things like structural equation modeling, for instance. They help you rigorously test if your conceptual map actually aligns with the reality you see in the data.
Okay, testing the fit between the idea and the evidence.
Exactly. How well do the findings match what the theory proposed?
So they almost sound like rivals, don't they? Discovery versus validation.
It can be presented that way.
But you said earlier the real magic happens when they're combined. How does that work? How do these seemingly opposite approaches actually help each other out?
Right, and this is where it gets really interesting, because the deepest insights often come from this interplay.
Okay.
So while they seem opposite, they're often used in a really complementary way. Think about it. Those unexpected patterns you find from a purely data-driven look.
Yeah.
Those can actually spark brand new theories, ideas you wouldn't have had otherwise.
Oh, wow. So the data doesn't just confirm theories, it can actually give birth to them.
Exactly.
Like, say, a data analysis finds people taking some random supplement get over colds faster. Just a pattern.
That data point could then spark a theory for researchers. Maybe compound X in that supplement does something specific to the immune system, and then they design studies to test that theory.
Precisely. It's a feedback loop. Data insight leads to new theory.
That's powerful, and I guess it works the other way too. A good theory can help you navigate the data.
Absolutely. If you have a strong theory, it can tell you which variables to focus on in a massive data set, or which kinds of analyses might be most fruitful. It makes the data exploration more efficient, more targeted.
Instead of just boiling the ocean looking for anything?
Right. So especially now with big data, it's really common to use data-driven methods to test theory-based hypotheses. Or you find something with data mining, and then you use existing theory to try and make sense of it, to interpret it.
So it's about using the strengths of one to cover the weaknesses of the other.
That's a perfect summary. Leverage both.
Okay, so the big takeaway here isn't really about picking team data or team theory.
No, not at all. It's about understanding that the real power often lies in strategically mixing them, using both the surprising insights from data and the structured explanations from theory.
Getting a more complete, more robust understanding that way.
Right.
And, this raises a really interesting question for you, the listener. Think about the information you consume every day, or maybe problems you're trying to solve. How much of that knowledge feels like it's built purely from patterns someone spotted in data? And how much is guided by existing ideas, existing frameworks you already hold?
Yeah. Is it bottom up from the data or top down from a theory?
Exactly. And just thinking about that distinction, where the knowledge you encounter comes from, well, it can really change the kinds of questions you ask about it. Something to mull over.